Welcome to a discussion of the power of the unit circle when it comes to trigonometry. What I've got here is I've got a unit circle, radius 1 here. It doesn't show up really well, but we have radius 1. Therefore, on this unit circle, we know we have the following points. This point would be 1, 0. This point would be 0, 1. This point out here would be negative 1, 0. This point would be 0, negative 1. And all of these dots are our really nice trigonometric values to work with. This would be 30 degrees, 60 degrees, or 45 degrees, 60 degrees, and 30-degree reference angle, 45, 60-degree reference angle in each of the quadrants. Okay, now, the values you're seeing here below that I'm referring to as short, because the short distance is 1/2, the middle distance is root 2 on 2, and the long distance is root 3 on 2. All of those values come from our triangles. For instance, here's let's say this is a 30, 60, 90. And back from your basic geometry, we should be able to, if we know one side, find all the other sides. And if I call this side 1, because we're on a unit circle, radius 1, that hypotenuse, if you see what I'm outlining here, is always 1. Well, the ratio from longest side to shortest side is 2 to 1 or 1 to 2, depending on which way you go. So this is 1/2. From short leg to longer leg, we multiply by root 3, so this is root 3 on 2. So this point means to get there, we have to go over root 3 on 2 and up 1/2. Likewise, I think you can see if I spun this around, flipped it over for my 60, 30, I'd be over 1/2, up root 3 on 2. And similarly, this value and this value come from working with our 45s. So if we had a 45, 45 right triangle, if this side was 1, our ratio from here to here is root 2. This would be 1 divided by root 2, or of course root 2 on 2 when we rationalize. So I've broken this down into our movements to the right, left, our movements up, down. If we are right here, we have a short movement to the right and a long movement up. If we're down here, we've got a middle movement to the right and a middle movement down. If we're here, we're short to the left and down long. And if we can remember that this is our short, they're always over 2. If you like, we could even treat this as 2 over 2, 0 out here, and call that 2's bigger than root 3. Call this the longest, and then we could have a shortest. But I think the quadrantals are so easy to work with. Let's talk about these special 30, 60, 30, 45, 60s that occur along the route. Okay, so if we get that, then we should be in good shape coming up with, say, the ordered pair over here. The ordered pair over here, this is long to get there. I bypass that point. I bypass this point. I go long to get there. That's a root 3 on 2, but it is to the left. And then I go up. That's a short. It's up 1/2. And why is that so useful? Because on a unit circle, the sine of theta, let's take a look at this one right here. The sine we know is SOHCAHTOA. Sine of theta, this angle is opposite. That's y. That's my y value over hypotenuse. But when hypotenuse is 1, it's just pure gold. So my sine is just this value right here. So the sine is the y value. So the sine of 30 degrees is 1/2. The cosine is the x value. The cosine of 30 degrees is square root of 3 on 2. How far over I went to get there. Then all we have to do in the other quadrants is account for positive and negative. This is going to be right, left first, short and left, followed by long and down. And that is just gold, as I said earlier. Can't repeat it enough. Sine of then what do we have here? This is 180 and 60. Sine of 240 degrees is negative square root of 3 on 2. Cosine of 240 degrees is negative 1/2. So I would challenge you to become really good at filling this guy out. Coming up with any of these points, and it could be maybe I just want to go through and get my x values here, but I think I'm going to go point by point. So this would be 1 0 0 1 negative 1 0 0 negative 1. The quadrantals are easy. To get to this point, it's long, root 3 on 2, and up short, 1/2. This one is middle. Middle is root 2 on 2, and up middle, root 2 on 2. Short, 1/2, up, root 3 on 2. Short, 1/2, but to the left, up, root 3 on 2. Middle, middle, root 2 on 2, root 2 on 2, but left and up. It's a terrible 2. Left, long, up short. Long, root 3 on 2, but left, up short. Let's go to this problem. Long and left, I'm going to this one right here. Long and left, negative root 3 on 2. Short and down, negative 1/2. Middle to here. This is the middle point as I go left, right. Middle, root 2 on 2, but that's left. Down, middle. Down, middle. Negative root 2 on 2. This point, short and left, negative 1/2, down and long, negative root 3 on 2. Short and right, 1/2, down and long, negative root 3 on 2. Hey, these are supposed to be smudge-proof pens. What happened here? Middle, middle, root 2 on 2, 2, root 2 on 2, 2 of those I mean, but this one is to the right, so positive, this one's down, negative. And to get to this point, long and down. Root 3 on 2, square root I should say, square root of 3, sorry if that offends anybody. Square root of 3 on 2, and to get down, short. 1/2, but down. Why is that valuable again? When we get a problem like, for instance, let's say we need to find cosine of 210 degrees. If we know where 210 is and it's a good reference angle, I've got that ordered pair right now on a unit circle. That's long to get here, and left, negative root 3 on 2, and I've got cosine right there. And short and down, sine of 210 right there. I would challenge you, if you're following this, if that makes sense to you, I'd challenge you to try to do this just in your head. For instance, if I have sine of negative 30 degrees, sine of negative 30 degrees, try to visualize it. Sine of negative 30 degrees would be a long point. It would be long and to the right, so root 3 on 2, and it would be down but short. Sine of negative 30, negative 1/2. It would have been, this is what I was envisioning right here. Long and down. Long and down short. So that can be just huge for you moving on. It's really easy just to say, well, let's just build the triangle, build a 30-degree triangle, and let's go. If it's 30, I could put a 1 here and a 2 here and a root 3 here, and I could say, oh, the sine of it's 1/2, and since I'm in quadrant 4, it's negative. But this could be really, real huge time saver for you when you're finding trigonometric functions. So hope that's helpful. I think it's a big part of me wishes I could back up my teaching career a lot of years, and we've had really fabulous results with this just in the last day or two. It's something I'm really excited about, and I hope you give it a look.